Happy Monday, everyone. Thanks for tuning in for another Union Station live stream. My name is Patrick Hess. I'm the Planetarium Specialist at Union Station. You may have seen my evil twin giving live streams in the past few weeks, but trust me, his information was just as good. That's why I might look a little different. No, this is still me. This is still Patrick, and we are going to be taking a little tour of our night sky today. And if you are just tuning in for the first time, welcome. We're so glad you're joining us for these special live streams. And if you're returning, thanks for tuning in once again. Hopefully you'll learn something new on this stream. Just a little recap of what our schedule looks like right now. We're going to be streaming on Mondays, Wednesdays, and Fridays at 6 p.m. Mondays is our What's Up for the Week stream, where today we are going to be taking a look at what you'll be able to see this week in our evening skies. I'm also going to throw in some space news that you might be interested in, some fun discoveries or announcements that may have happened in the world of space exploration and astronomy over the past week to kind of give you a little update and keep things fresh. Wednesdays will be a special deep dive topic day where we're going to take an in-depth look at a special topic in astronomy. So far we've covered the solar system, doing a solar system tour. And then last week we did a little feature about stellar evolution, and we learned about how stars are born and how they die. You can find recordings of all these streams, by the way, on the Union Station Facebook page. You can rewatch any of these if you'd like, or catch any of them that you may have missed. If you're watching on the Union Station stream, just be sure to like and subscribe to the Planetarium Facebook page. We're streaming there as well as the Science City Facebook page. And one last thing, I wanted to give a special shout out and thank you to all of our 10,000 Union Station members. Thanks so much for continuing to support us during these crazy times. And if you're looking for other ways to support Union Station, just head over to unionstation.org and you can find out more information there. Next Wednesday's live stream, I will announce the topic for that at the end of this stream, so be sure to stay tuned and stick around for that. And then, oh, by the way, on Fridays are our special Fan Friday. And on Fridays, we are going to be answering your fan questions. And that'll be a day dedicated to questions and answers. I won't have a specific outline for those days planned, but we'll have plenty of time to answer questions. That being said, today, feel free to throw any questions you've got in the comments section, and we'll write those down and hopefully be able to answer some of them today. But we may not have time to, and we'll be sure to keep them for those Friday live streams if we miss any of those questions. So don't worry, ask a question, and sorry if we miss it, but we'll for sure answer them before the end of the week. So let's talk a little bit about some exciting space news. We're using some natural lighting today, so things might get a little crazy, and I'll do my best to adjust as time goes on. I think we might be getting sucked into a black hole. That's the wrong way. There we go. That's how you know it's live. I look very tan right now. Awesome. So let's talk about some space news. It's already Monday. I can't get too off track. So one big announcement that just happened a couple days ago is NASA announced that on May 27th of this year, weather permitting, we are going to be launching American astronauts for the first time on American soil since 2011, which was the end of the space shuttle program. For the past decade, basically, American astronauts have been hitching rides over in Russia aboard their rockets, and we've been sort of bumming rides with them, getting to the International Space Station. And this is just really exciting that finally we'll be able to send our own astronauts to space. And there's nothing wrong with collaborating with other countries' space organizations. But it is exciting that we'll have the capability to send astronauts up there ourselves. And these astronauts will be sent to space aboard a spaceship from SpaceX, which is a private space company who has been sending satellites and probes into space for a number of years now, but they just have gotten approved to send human astronauts into space. They'll be sending astronauts aboard the Crew Dragon capsule. Now, this is a picture of the interior, which looks pretty fancy and pretty different from what a lot of us are used to seeing when we look at like Apollo space capsules with a lot of dials and and buttons and things. Definitely looks a little bit more modern and clean, but you can see there. So we will be sending two astronauts, Doug Hurley and Bob Behnken, and they'll be above this Crew Dragon space capsule. And that will be attached to a Falcon 9 rocket, which is a reusable rocket from SpaceX. So I believe they're planning on having that rocket land back here on Earth so they can reuse it. They have reused these Falcon 9 rockets, but I do know that for this mission they're going to be using a brand new one, even though the used ones are just as reliable. But you just want to be sure when we're sending humans up there. So you can see here, a lot of these systems will be automated. So that's why there are far fewer buttons. But yeah, pretty cool. So they'll be sending astronauts aboard this capsule, hopefully on Wednesday, May 27th. Be sure to stay tuned to the Planetarium Facebook page. We'll be posting a lot of updates about that as we get closer, as well as updates if they end up rescheduling that. And then that Wednesday live stream we'll definitely be dedicating to that launch and talking a little bit more about it, looking at video clips from it and sort of diagnosing all that. So stay tuned for that. May 27th, very exciting date on the calendar. Another fun announcement that was just made recently has to do with black holes, and this is pretty exciting. So a few days ago, the Max Planck Institute for Extraterrestrial Physics, they revealed that one of the stars orbiting the black hole at the center of our galaxy was behaving in a way that was predicted by Einstein's theory of relativity. Now, I've talked about during a few previous streams that we've been monitoring the stars that are orbiting the supermassive black hole at the center of the Milky Way. And they're moving so quickly that when we take pictures of them year to year, we can actually see them move and observe their movements and measure them and record them. Well, one of the stars, named S2, which is one of the closest stars to the supermassive black hole, we've been recording for about 30 years. And finally, we got enough information to confirm that its orbit follows Einstein's theories of relativity. Now, Newtonian gravity, which is the theory of physics that basically we thought covered everything until about 100 years ago, explains and only accounts for bodies moving in elliptical orbits, so standardized orbits that stay in the same shape, basically. But Einstein predicted that orbits may actually change shape, and specifically they may precess, they may actually move forwards along their orbital plane. And so to show you a picture of what we're talking about here, instead of an orbit staying elliptical like this, we've actually observed this star's orbit as sort of following this kind of rosette shape and actually precessing and moving sort of forwards along this orbital plane. So it took 30 years of observations to confirm this, that this star is moving in this direction, but this is just another sort of a tangible and observational piece of evidence that does confirm Einstein's theories of relativity about how gravity can bend the fabric of space-time and change these things out in space, like orbits and light. This star is moving pretty quickly at about 3% the speed of light, which we call relativistic speeds. Most everything moves a lot more slowly, nowhere approaching anywhere close to this, the speed of light, or even 1% of the speed of light. So this star is moving very quickly, and it orbits all the way around about once every 16 years. That's kind of interesting. We've actually observed Mercury behaving in this same way, albeit in a much less pronounced way or exaggerated way, I guess. But Mercury has an elliptical orbit that does precess and move forward. So we've already observed these things in our own solar system, but observing that around a supermassive black hole just confirms those theories even more. So there's one more piece of news, but we're going to cover that during our star tour. It's the Lyrid meteor shower, so be sure to stay tuned. We are going to talk about that later in our star tour, which we're going to jump into right now. We did get a question real quick from Eric about the astronauts aboard the Dragon capsule. Are they NASA astronauts? They are indeed NASA astronauts, and I believe they've all flown on previous missions. But we can confirm that. So let's see who's going to be. All right, so looks like Doug Hurley is an American engineer and NASA astronaut. He piloted a space shuttle mission in 2009, and he also piloted the final space shuttle flight in July of 2011, actually. So he's a NASA astronaut and pilot. And then Bob Benkin is an Air Force officer, NASA astronaut, and the chief of the astronaut office, and he holds a PhD in mechanical engineering. So both NASA astronauts, and very exciting that they'll be first Americans to go into space after a long time on board an American spacecraft. All right, so let's jump into our star tour. We're returning to Stellarium, which is a free piece of software you can download at home. And we're looking at our Kansas City horizon here, looking at Union Station, standing on the steps of the Liberty Memorial at the World War I Museum and Memorial. And we can see the sun setting over in the west here. Now, we're going to be looking at a simulated view of our night sky, but as I've mentioned before, the simulated view of our night sky we're going to see is not going to be the scene you'll see in this exact spot in downtown Kansas City. This is thanks to light pollution. All these buildings and man-made light sources like street lights and car headlights will drown out a lot of the starlight when you're near civilization, near a big city, or even a small town or the suburbs. If you want to go stargazing, you'll have to travel about an hour away from downtown Kansas City, and you'll be able to see the stars much more clearly from there. But in our simulated view of the night sky, we have sort of flipped the light switch on Kansas City, and we can see the stars much more clearly, imagining no city lights on. So I like starting in the northern night sky, and again, if you've tuned in before to our star tours, some of this stuff may be familiar, but the night sky is constantly changing, so it's always good to be refreshed about where certain things are. So I like starting with two very familiar patterns, the Big and Little Dipper. These are two spoon shapes that a lot of us recognize in our northern skies. We can see them year-round, although they'll be in different positions and different orientations depending on the time of year. Right now, the Big Dipper is above the Little Dipper. We can see the handle of the spoon right here, as well as the scoop. And then the Little Dipper below it, its star is a bit dimmer, but there is the handle and its smaller scoop. Now, these two shapes are very well-known patterns in our night sky. However, they are not official constellations. There are 88 official constellations. These were actually picked back in 1930 by the International Astronomical Union, which is the same group of people who recently demoted Pluto. So we can all thank them for that one as well. So there are 88 of these patterns. 42 of them are animals, 29 are inanimate objects, and the other 17 are humans or figures from mythology. But those are the official star patterns, and the Big and Little Dipper are not official star patterns. They actually belong to a different category, a category we call asterisms. An asterism is an unofficial pattern of stars, so any shape that's very well known and famous but is not one of the official constellations. It makes sense that we have this other category because when you think about it, 88 is not a big number, and on a clear night, humans can see around 2,000 stars with the naked eye, so it stands to reason that people around the world probably see more than just 88 shapes, so how could we settle on just those 88 patterns when there are all these other famous shapes? Well, we do that by just having another category for those other non-official shapes, and we call them asterisms. There are two official constellations that use these same stars. They're called Ursa Major and Ursa Minor. That means the Big Bear and the Little Bear. The Big Bear contains the stars of the Big Dipper. The tail of the bear is the handle of the spoon here. The body of the bear contains the spoon plus these two stars. The head of the bear goes over to this star. And its legs extend up into the sky. During the spring and summertime, Ursa Major, the Big Bear, is kind of upside down. Again, there's the tail, the body, the head, and the legs. Ursa Minor, the Little Bear, its stars are a bit dimmer, but they form a similar pattern, so you can imagine the same tail and bear's body and head, although you kind of have to use even more of your imagination to imagine the legs. There aren't many bright stars down there, but again, sort of a similar pattern. Let's see if we can go ahead and put these two constellations up there. We want to... Wrong button. All right. Okay. So Ursa Major and Ursa Minor, the Big and Little Bear. Now we've gotten a common question the past few times, so I'll just bring it up right now, but bears do not normally have tails this long. Now it is sort of a mystery lost to history as to why these bears in the sky have these long tails. There are different theories surrounding translation errors between native cultures, but more than likely these are just patterns whose shapes and stories sort of evolved and changed over thousands and thousands of human history, years of human history. So sometimes things just sort of get conflated. If you've ever played a game of telephone, you can kind of imagine why these things might change. Now there is a very famous and important star at the end of the little bear's tail that's worth mentioning. This star's official scientific name is Polaris. You can see labeled in the upper left-hand corner. This star does have a very famous and more well-known nickname. Call it the North Star. Now, the North Star is special, but it's not special for the reason you might think. It's a common misconception that the North Star is the brightest star in the sky, but that is definitely not true. In fact, you can see other stars in this view alone that are much brighter than Polaris. Polaris is actually the 45th brightest star, so it's not even anywhere close. In reality, the North Star is special because it does something kind of strange throughout the night. Now, this is the early night sky, right? But you might have noticed as the sun set that the stars don't stay in the same place all night. They'll actually move positions. If we fast forward time, you'll see that throughout the night, stars will appear to move. They'll be setting in the western sky, dropping out of sight throughout the evening. And in the eastern sky, they'll be rising. Now, can anybody think of any other famous stars that rise in the east or set in the west? If you said the sun, you are absolutely right. The sun is a star, and it does the same thing. But the sun and the stars aren't actually spinning around us. We are spinning. The Earth is rotating around its axis once every 24 hours, and since all of us happen to be on Earth right now, from our perspective, it looks like the stuff in the sky is moving. I'm going to rewind time here. As you can see, all the stars are moving, but they're following a pattern here. They're rotating around a single point, and that point, you might have noticed, is Polaris, the North Star. The North Star is special because it's the only star that doesn't move. It stays in the same place all night. So no matter where you are on planet Earth, and no matter what time of night it is, if you can find that North Star, you can always find north, because the North Star always points north. We're going to return back to our evening sky. Not too far. By the way, our star tour is looking at our skies about an hour after sunset, which, as you can see, is about 9:30 p.m. And that's just because right when the sun sets, there's still twilight and all the stars have not come out yet. But if you wait about an hour, that's usually enough time for all the twilight light to dissipate and for you to see the stars more clearly, especially if you get far away from the city lights. Now there's a nifty little trick you can use to find the North Star. If you can find the Big Dipper, which you usually can see it in the northern hemisphere here, just take these two stars at the end of the bear's spoon, or the dipper's spoon rather, and extend it down towards the horizon in the spring and summer, and that line will point right at Polaris. Now this is our Kansas City night sky, I should mention, and I know we have viewers that are tuning in from around the world. The night sky will change depending on what your latitude is, so how far north or south of the equator you are. So if you're anywhere on Earth at about 40 degrees north, which is what Kansas City is, then you'll see the same sky, albeit at different times. If you travel north, the North Star will be higher in the sky, and if you travel south, it'll be lower in the sky. At the equator or anywhere further south, you will not be able to see the North Star because it'll be below the horizon and the Earth's curve will be blocking its view, basically. If you were at the North Pole, however, and you shined a light straight up into the sky, it would point right at the North Star. And in fact, that's how it gets its name, Polaris, as in it's directly above the pole, the North Pole. We're going to move right along to our western sky. A lot of fun stuff going on in the west in our evening skies right now. And the first thing you'll probably notice is this incredibly bright point of light setting in the west. This point of light is so bright you'll even see it in the daytime sky before the sun finishes setting. You might think that this is just another star, but there's something different about it. Can you spot it? Compare this point of light to the stars nearby. You can see in our simulation here very clearly. What do you notice the stars are doing this object is not doing? Can you see the stars twinkling? They twinkle here in our simulation just like they do in the real night sky, but this object is not twinkling. Now, the reason stars twinkle is because they're very far away from Earth, and it takes a long time for a distant star's light to reach our planet. By the time a star's light does get to the Earth, only a tiny little amount of it is able to pass through the Earth's dense atmosphere, and our atmosphere, all those gases above our head, causes that little bit of light to become distorted, making it appear to wobble and twinkle. That's why stars twinkle in the night sky. But this object right here is a lot closer than distant stars, so a lot more of its light is reflected back towards Earth, and it appears as a wider disk of light, so it's not disrupted by our atmosphere, and it doesn't twinkle. This is a planet. Again, just to reiterate, you can tell it's a planet because it's not twinkling. You can also tell it's a planet because it won't be in the same place every night. Planets actually appear to wander around our night sky as they orbit the sun at their own pace. That's actually how they got their name. The word planet means wanderer in ancient Greek. And this particular wanderer you'll see tonight is the planet Venus. Let's zoom in on our sister planet, Venus. Now, Venus will be the brightest point of light in the night sky tonight. It's the second planet from the Sun, and we nicknamed it our sister planet because it shares a lot of similarities with the Earth. It's about the same size as the Earth. It has a solid rocky surface like the Earth, it has an atmosphere like the Earth, and it has clouds and weather patterns, and it even has rain. When we zoom in far enough on Venus, we see that it's actually in a crescent shape. This is because Venus is closer to the Sun than the Earth is, so Venus actually appears in phases. It'll also always appear in the early morning or early evening sky. That's why it sometimes has the nickname the morning star or the evening star. It's not a star again, but it is very bright and it stands out. And again, it will always appear in the early evening or early morning, right around the Sun. It'll never appear around midnight. Now, Venus's clouds are a lot thicker than the Earth's, so Venus is much different in that way. Its clouds have caused a runaway greenhouse effect, which has heated the surface of Venus to over 900 degrees Fahrenheit, and can get the hottest planet in our solar system. I wouldn't recommend spending your vacation there. Let's zoom back out here. Venus will soon be out of sight, though, so be sure to check it out, setting in our western skies right now in our spring skies. Now, there are a couple constellations that are setting that were prominent in our winter skies that you won't be able to see for much longer. We might just be able to make out the head of Taurus the bull. This V shape is the bull's head, and then his body kind of goes downward towards the horizon, but pretty hard to see right now. Its horns go up there, though you can still see them. Taurus represents a disguise that Zeus, the king of the Greek gods, used to take when he came down to Earth to mess around with mortals. He used this bull disguise to kidnap a young princess named Europa. Europa, by the way, is the name of one of Jupiter's moons, and Jupiter is the Roman version of the god Zeus. It turns out that many of the moons of Jupiter are actually named after various children that were kidnapped by the king of the gods. There's a pretty cool deep space object also setting in the west. You might be able to catch it in the early evening, about 30 minutes after sunset. But again, you can see it's pretty close to the horizon right now. You can zoom in on it, though. This is the Pleiades star cluster, or Seven Sisters. It's nicknamed the Seven Sisters because most people can see 6 to 7 stars here with the naked eye. In reality, though, this star cluster contains about 2,000 stars that are all bound together by gravity. These stars are also siblings. They're all born together from the same nebula. We actually looked closely at the Pleiades star cluster in 3D during our live stream last Wednesday, where we learned about the evolution of stars and how they're born. These stars are all very young stars, and we can see the nebula that they were born from reflecting the blue light from them. So if you want to learn more about the Pleiades star cluster and how stars are born, be sure to tune into last Wednesday's live stream. I'm getting an update from our guy in the chair saying that there are some technical issues with Facebook Live right now. So I do apologize if you're having trouble viewing us. But if not, we're going to continue touring, and we will record this. So we'll post this if there are any issues. But I do apologize for any technical issues. But we're going to continue on, assuming that there are 1 million people watching me right now. That might be too much pressure. Let's pretend there's 10,000 people watching me. And we can see one of my favorite constellations just peeking out above the trees here. In fact, I can change the settings to a more level playing field here. So this is if you were out in the country far away from the city horizon, you'd be able to see Orion setting in the west. Orion is the brightest constellation in the night sky when you combine its stars. Many people recognize Orion's famous belt outlined by these 4 stars. Here are Orion's shoulders and here are his feet. This little cluster of stars is Orion's head. In one hand, you can imagine him holding a shield or a bow, and the other is raising a club or a sword. Go ahead and that constellation up there. Now, Orion is a famous character from Greek mythology. Orion was a famous hunter that was well known around the world, but he also liked to brag about himself. One day, Orion boasted that he was such a good hunter he could capture every animal on Earth if he wanted to. When Artemis, the goddess of the hunt, heard this boast, this made her very upset. After all, it was her job to protect the animals on Earth, so as punishment she sent a giant scorpion monster down from Mount Olympus to battle Orion and teach him a lesson. The scorpion and the hunter fought for days and days, and their battle is now immortalized in our night sky as the constellations Orion and Scorpius chase each other between the seasons, never appearing in the night sky together because Orion's a winter constellation and Scorpius is the summer constellation. Let's go ahead and turn those constellation lines off here. Now, one thing I haven't really mentioned during previous star tours is the Milky Way galaxy. And that's because it's kind of hard to see in the springtime. Right now, the Milky Way is sort of lined up very nicely with the horizon, which means it's really disrupted by our atmosphere and kind of hard to spot. That's why I haven't really mentioned it. It is much more prominent in our summer skies. Or if we fast forward to later in the evening, say in the early morning, in fact, we'd be able to see it stretching up from the south here. Again, this is right before sunrise, actually, about 4:30 a.m. This will be prominent in our early summer evening skies. And we did get a question from Craig about galaxies and moving. Now, he's talking about galaxies moving away from the center of the universe. And something called redshift. Now, we're not going to get too in-depth here, and maybe this could be a topic we could cover in a future Wednesday stream, but I'll just briefly kind of talk about that. So we have discovered that the universe is expanding, and the way we discovered that is by looking at other distant galaxies and measuring the light that they're emitting, and we can see that the light they're emitting is sort of shifted in its spectrum because of something called the Doppler effect. If you've ever heard an ambulance sort of drive by your house, you might have heard its pitch lower as it went by. It would start high, like dee-doo-dee-doo, but then as it passed you, it would go dee-doo-dee-doo-dee-doo. It would get lower. And that's because of the Doppler effect. Sound travels in waves, and as sound waves, if a car is moving towards you, sound waves that it's emitting are compressed. But as it moves away from you, they're going to be expanded, and that's why that pitch changes. Well, light behaves in waves, and it does the same thing. And so by measuring the shifting of light in distant galaxies, we can measure the speed at which they're moving away from us, and there we can measure the rate of expansion of our universe. So that's a little bit about redshift, Craig. Hopefully that kind of answers your question and a little bit ties in with our tour. But again, just mentioning our Milky Way galaxy, you won't be able to see it in the early evening tonight. But let's go ahead and return back to our evening star tour at about 9:30. I did just want to touch on one more thing in Orion. Below Orion's belt, you'll see a smaller group of 3 dimmer stars. Some people call this his dagger or his sword hilt. This is actually hiding one of my favorite deep space objects, the Orion Nebula. This is another place we stopped by during our stream last Wednesday, so be sure to check that out if you want to learn more about how stars are born. The Orion Nebula is a stellar nursery, a birthplace of new stars. And this gas and dust is forming new stars. You can actually see 4 new stars in the center of the Orion Nebula. They're not simulated here, but they are visible through a pair of binoculars. They're called the Trapezium. That's kind of a fun space name. But they are baby stars that were born a couple 100,000 years ago. But this nebula is actually visible through a moderately powerful telescope, even a intermediate one you could purchase for yourselves. So this is one of my favorite things to look at. So if you do have a telescope, be sure to check that out before Orion sets in our spring skies here. I mentioned that Venus is the brightest point of light, but the brightest actual star is just to the east, or sorry, the south, I guess, of Orion. If you draw an imaginary line through Orion's belt, it'll point right at this star. This is actually the brightest star in the entire night sky. Seriously. The star's name is Sirius. Sirius is also nicknamed the Dog Star. It's part of a dog constellation named Canis Major. This was one of Orion's hunting dogs. This is also where the term dog days of summer comes from. In the summertime, you can see Sirius rising in the early morning sky. And that signifies the arrival of the season. That's why we say the dog days of summer. By the way, if there are any Harry Potter fans watching now, it might make a little more sense to you now why one of the characters in that story is called Sirius. I did want to call back to Craig's question about redshift. I realized I didn't completely answer that. He was asking if we used redshift to find the center of the universe. And this is a complicated question to answer. There really is no center of the universe because the universe is expanding. So from anywhere you are in the universe, it looks like the universe is expanding away from you. So it's kind of hard to explain, but you can kind of imagine the universe like a balloon that's inflating. So if you drew a smiley face on a balloon and blew it up, every point on that smiley face would be expanding away from each other, so there really wouldn't be a center. It's all sort of expanding in the same way. So hopefully that answers your question. There really is no center, and I know that's kind of hard to intuitively imagine, but I'll have to take my word for it. We're going to move right along. Looking at our southern sky, a little bit higher in our southern sky, you'll find Leo the Lion. This is a fun constellation you can use an asterism to identify. This asterism looks like a backwards question mark or a coat hanger hook. This is Leo's head and his mane. Here's Leo's body, his front paws, and his tail. Kind of looks like he's lying down. Anybody? Lying down? Just me? Oh, right. Well, I'm in quarantine. Leo represents the Nemean lion. This was the ferocious beast that Hercules fought and defeated during the first of his 12 labors. The brightest star in Leo is at the front here. It's called Regulus, which means Little King. And the star at the end of Leo's tail is named Denebula, which means Tail of the Lion. Moving right along to this star down here. This star is named Spica. This star is part of Virgo the Maiden. This one looks like a big stick figure. Spica is one of Virgo's hands. Here's her arm and her other arm. Here's Virgo's head, then her body, and her legs. Virgo represents a goddess of fertility or harvest. The Greeks called her Demeter, the Romans called her Ceres, the Egyptians knew her as Isis. She's often depicted as carrying an ear of grain in one hand. In fact, Spica means ear of grain in Latin. And look, the constellation is holding Spica. The second brightest star in the night sky right now, and the second brightest star in the northern hemisphere overall, is this one right here. Its name is Arcturus. Arcturus means watcher of the bear, and this constellation is called Buotus, and he was sort of a bear hunter or a shepherd watching out for bears, protecting his flock. Kind of looks like a spilled ice cream cone, in my opinion. There's actually a fun little saying you can use in our later spring skies to remember Arcturus and Spica. First, you got to find the Big Dipper. You can see it shining over here in the northeast. Now, if you look at the Big Dipper's handle, you can see it's sort of shaped like an arc. If you extend that arc across the sky, you can kind of imagine it passing through Arcturus and Spica. Now, there's a little saying that goes along with this, so just remember arc to Arcturus and speed on to Spica. Again, just arc to Arcturus and speed on to Spica, and you can easily find and remember these two stars. Now, if you combine Arcturus, Spica, and Denebula, it forms a nearly perfect equilateral triangle in our spring skies. And this is actually nicknamed the Spring Triangle. This is an asterism that ancient people used to help them figure out the changing seasons. The way this works is that in the winter time, you'll see these three stars rising one after another, but eventually you'll notice that all three of them are up after sunset, and that tells you that spring has arrived. The Spring Triangle has a more famous older cousin named the Summer Triangle, and we'll be looking at that later in the season. But there are numerous sort of shaped asterisms like this that ancient people use to figure out the changing seasons, and again we can see the Spring Triangle here. Once the Spring Triangle is high in the south after sunset, then summer has arrived, and by then we'll see the Summer Triangle. But actually, I'm going to show you a little tease for the Summer Triangle, because the last little bit of space news that I was going to mention is the Lyrid meteor shower. Now, this meteor shower is not going to be visible until much later in the evening, and you'll have to wait until the constellation Lyra rises in the east. We're going to fast forward time here until a little after midnight. So here is right around midnight. You'll see a very bright star named Vega near a little diamond in the sky. This is the constellation Lyra. Now, Vega is part of again, the Summer Triangle, and this is the first star of it. In fact, we can see the second star of the Summer Triangle right over here, but again, we're not going to talk about the Summer Triangle now. I do want to talk about the Lyrid meteor shower, though. This meteor shower is going to be taking place this whole week. It'll be at its brightest from about the April 21st to the 25th, so pretty much this whole calendar week. This should be a decent meteor shower. We're lucky that it coincides with a new moon, so the moon is not up. We didn't visit it during our star tour because you can't see it right now. That means it'll be really good viewing conditions because that moon is actually a source of light pollution. So without the moon there, it'll be even easier to see these meteorites. The official peak, the time when it should be the most active, will be late Tuesday night to early Wednesday morning, so around midnight Tuesday night / Wednesday morning. Now, the Lyrids is a pretty good average meteor shower. It's not one of the better ones. The Perseid meteor shower in August is one of the most famous. During that meteor shower, you can see about 75 per hour. But the Lyrid meteor shower will be about 10 to 20 meteors per hour. So you'll need to be a little patient. It may take a few minutes between each meteor, or meteorite. The way to spot them, though, is you want to look towards the constellation Lyra. All meteor showers are named after the constellations that they appear to emanate from. So the meteors will be kind of emanating from this direction, from the constellation Lyra, which again you can find by looking for this little diamond near a bright star rising in the northeast around midnight this week. Meteorites and meteor showers sometimes are nicknamed shooting stars. They're not stars, though. They're particles from space entering the Earth's atmosphere. Many of them are very tiny, microscopic, but they're traveling at tremendous speeds, and once they enter our atmosphere, tremendous forces are acted upon them, and they will glow red hot and sometimes even ignite, which we see as shooting stars or meteorites. Now, meteor showers are annual. We can predict them, mostly because most of these meteor showers are from clouds of debris left over from passing comets and asteroids, which the Earth passes through at regular intervals, once every 365 days, as it circles the sun. So if this cloud is right here, every time the Earth passes it, we'll have a meteor shower, and we can predict those annually. And sometimes they'll be brighter or less bright than other years, but this is an average year for the Lyrids. Again, 10 to 20 meteors per hour, right around midnight near the constellation Lyra, towards the northeast, the bright star near the little diamond. That is the Lyrid meteor shower. And that brings us to the end of our star tour for tonight, or for this afternoon, I suppose, and for the week. So thank you all so much for tuning in. Again, I don't know if anybody's watching live right now because we did have technical difficulties, but if you are, thanks for sticking with us. And if not, thanks for tuning into our stream. Once again, we should be able to catch the recording of this stream if there were technical issues. So check that out. And if you have any questions on the recording, feel free to drop those in there, and we'll be sure to write those down and hopefully answer them on Friday. And I do want to announce our topic for Wednesday's deep dive live stream. This Wednesday, I'm going to be taking a look at the Messier catalog of deep space objects. The Messier catalog of objects is a list of about 110 sort of best of space things. It was a catalog started by an astronomer named Charles Messier, who was actually a comet hunter, but it contains some of the coolest and most just awesome deep space objects like galaxies and nebulas and star clusters. So I'm going to pick a few of my favorites, and we're going to kind of do a deep dive into them, look at some of them in 3D, look at different light imagery from them, learn about how they were imaged and what we know about them. So hopefully that'll be kind of a fun change of pace. We'll be looking at a lot of deep space photographs, and it'll just be kind of a greatest hits of space photography, but also looking at some 3D imagery as well. So tune in on Wednesday for a best of the Messier catalog. And we will also be posting a full calendar for all of our Wednesday live streams, so you'll be able to tune in. And next Wednesday, I can go ahead and announce right now, we will be doing our live telescope setup and tutorial. So if you have a telescope in your garage or attic, be sure to take that out, dust it off, make sure all the parts are working. And if you need to find a telescope, maybe you can pick one up. I know delivery times are kind of iffy with online ordering, but you may find a good spot. One last question from Eric asking, what are some good places to view meteor showers near KC? And that's a great question. The main thing I would say, first of all, is to get away from the city lights. So if you drive about an hour away from town, usually towards the west, you'll have better luck. But you can also just Google search for a dark sky map. There are some great resources online. I just Google search dark sky map and found this map, which suddenly is appearing to not work. But you should have better luck on your computer. But this basically just shows you a map of light pollution. There are some great spots in parks. If you find a park that is open to the public, there's also the Powell Observatory down in Lewisburg, where the Astronomical Society hosts observing nights. That may be closed to the public right now, so you just be sure to check on that. But again, if you just, looks like it is working right now. Great, so this is Kansas City. If you just head, I would just kind of recommend if you head to a spot kind of in the southwest. It looks like there's some really good dark sky spots, but even a spot sort of in these blue areas should be pretty good. So find a nice spot far away from any street lights and as far away from the city or the suburbs as you can. and that'll be a good spot to catch the meteor shower this week, assuming the weather holds out. This will end it for our What's Up live stream for this Monday. Once again, Wednesday we're going to be covering the best of the Messier catalog of deep space objects, looking at some greatest hits of space photography. And we'll be posting a full calendar later. Be sure to tune in Friday. That's when we'll be answering all of your fan questions. And if we missed any today on the stream or on the recording, or if we don't have time to answer any on Wednesday, we will be picking those up on Friday for sure, as well as any other questions you chime in with live. That about does it for our stream today. I want to thank you all so much again for tuning in. I have a ton of fun with these, and I'm glad you guys are still watching. Hopefully we'll have a ton of fun content for you continuing on for the future. Once again, if you haven't liked and subscribed to the Gottlieb Planetarium, the Arvin Gottlieb Planetarium Facebook page, be sure to check that out. We'll be posting all sorts of space-specific updates there, especially leading up to the launch of the Crew Dragon capsule on May 27th. So like and subscribe there. Thank you all for joining. Once again, thanks to our members and to everyone who continues to support Union Station and Science City programs during this unusual time. Yeah, happy stargazing, folks. I'll see you on Wednesday. Bye, everyone. This has been Patrick Hess, your planetarium specialist, signing off, and we'll see you next time.